Today's lesson is on the applications of angles of elevation and angles of depression. Let's review from our learning objective is I can solve real-life problems involving right triangles by applying properties of angles of elevation and angles of depression. Let's review from geometry what an angle of elevation and an angle of depression is. When looking up to an object, the angle of elevation is formed by an observer's line of sight called the transversal and a horizontal line. So here is my angle of elevation. And an angle of depression when looking down to an object, the angle of depression is formed by an observer's line of sight, which is the transversal, and again, horizontal line. Okay, so here's my angle of depression. Why is this important? When I'm solving problems, I don't always have the triangle, the right triangle that I need to work with, but I have the angle of elevation or the angle of depression. And since all horizontal lines are parallel, the angle of depression is congruent to the angle of elevation. Along that same line of sight, which is the transversal. So taking a look at the measure of angle 1, here is my line of sight. So my two horizontal lines above and below that are angles 1 and angle 2. So angle 1 is the angle of depression. Angle 2 is the angle of elevation. So the measure of angle 1 is congruent to the measure of angle 2. Same thing is true for the second line of sight. Angle 3 is the angle of depression, and that would be congruent to angle 4, the angle of elevation. So I'm going to apply that property that those two angles are congruent. All right, so let's go into some problems here. Here's a standard trig problem from geometry. A helicopter is flying at an altitude of 1,000 feet. The pilot sights the swimmer at an angle of depression of 45 degrees. What is the distance from the swimmer to the island? So my right triangle does not have the angle. So I do know that the angle of depression along that same line of sight is equal to the angle of elevation. So I know this angle is 45 degrees. So 45 is my reference angle, so I want to know this distance here from the swimmer to the island. This is my adjacent side. This is my opposite side. So using my acronym SOHCAHTOA, I know I want to use tangent because I have the opposite and adjacent side. So I'm going to set this up as the tangent of 45 degrees equals the opposite 1,000 divided by x. So if I cross multiply, I'm really switching tangent of 45 and x because they're in logically equivalent places. So x equals 1,000 divided by the tangent of 45 degrees. Okay, since my question is in degrees, you want to make sure that your mode is in degrees. And I get x equals 1,000 feet. So for word problems, make sure we're using units. I should have also recognized that this is a 45, 45, 90 triangle, and these two sides are congruent. Okay, so that's from geometry. So let's move into pre-calculus, where we have multiple triangles on the same problem. Okay, so A pilot measures the angles of depression of two ships to be 40 degrees and 52 degrees. If the pilot is flying at an elevation of 33,000 feet, find the distance between the two ships. Okay, so angle of elevation, that is an altitude or a perpendicular height. So here's my right triangle here. So the angle of elevation of the airplane is 33,000 feet. Right now I'm being asked to find this distance here between these two ships. And my line of sight for 40 degrees is this line. So this angle is 40 degrees, and my line of sight for this line is 52 degrees. So this angle is 52 degrees. So now I have some right triangles. These are a little bit easier if you take them apart. I am going to set up and solve for this distance here. And I'm going to call that distance A for my 52 degree angle. And then I have a second triangle here that I'm going to call this distance from here to here the total B. And this is my 40 degree triangle. So this is 33,000 feet. So now I have a triangle that has three pieces of information: a 90 degree angle, a 52 degree angle, and 33,000 feet. So when I have three pieces, I can apply trig. So I want to solve for side A. So 52 degrees is my reference angle. So 33,000 is the opposite, and A is the adjacent side. So I'm going to set this up as the tangent of 52 degrees. Actually, I'm going to solve for the other one first. I'm going to set it up that way. I'm going to solve for the other one first, just by the way I want to do this. Okay, so I'm going to set up for and solve for B first. So I'm going to say the tangent of 40 degrees equals the opposite side, 33,000, divided by the adjacent side, which is B. So I'm going to solve for B. So B equals 33,000 divided by the tangent of 40 degrees. So B is approximately 39,327.869 feet. We went around 3 decimal places. And then I'm going to solve for A. So the tangent of 52 degrees equals 33,000 divided by A. So solving for A, I get A equals 33,000 divided by the tangent of 52 degrees. So I get A is approximately 25,782.426 feet. Now, why is that important? So if I know what A and B are, I can solve for X being B minus A. So the total minus the part A. So I'm going to get X equals B, which is 39,327.869 minus A, 25,782.426. So I get X is 13,000 545.443 feet. Okay, so this was an example where the two triangles shared the altitude. And the next example I'm going to go over here is the second way that I'm going to see two triangles. To estimate the height of a mountain above a level plain, the angle of elevation to the top of the mountain is measured to be 30 degrees. 1,500 feet closer to the mountain along the plain, it is found that the angle of elevation is 35 degrees. Find the height of the mountain. So this time, I'm trying to find the height of the mountain. And in the other example, I was given the height and I wanted to find the distance between the two triangles. So I'm given different pieces of information. So I'm going to go about this one a little bit differently. This one works out better if I take this oblique triangle here and divide it by dropping this perpendicular line and dividing that oblique triangle into two right triangles that share a side. By doing this, I can solve for this side that I just drew in. Let me draw that a little better. I can solve for this side that I just drew in first. Then I can solve for the hypotenuse of this triangle. And once I know the hypotenuse of the triangle I drew in along with the 35 degrees, then I can find the height of the mountain. So I'm going to call this first triangle, triangle number 1. The second triangle I created, triangle number 2. Oops. And this third triangle here, triangle number 3. Okay, so I am going to, in order to start working with these, I need to know what this angle is here. So I'm going to use the fact that I know the two acute angles in a right triangle total 90. So 90 minus 30 gives me 60 degrees for this angle. So I can set up by solving for side A in triangle number 1. So with 30 as my reference angle, I am trying to solve for A. So I'm solving for A and I have 1500. So that is going to be the opposite of the hypotenuse, which is sine. So the sine of 30 degrees equals the opposite A divided by the hypotenuse, which is 1500. So solving for A is 1500 times the sine of 30 degrees. When you're multiplying these, put the numbers to the left of the trig word. That's the standard way we see that. So the sine of 30 is a half. So I know A equals 750 feet. Okay, so for my next calculation, I want to solve for side B next. So to solve for side B, I need to know this angle in the triangle. And I know I'm forming a line here between these three triangles. So if I add up all three angles, I know all three total 180. So to find that angle, I'm going to take 180 minus 60 minus 35. So I get that angle is 85 degrees. So with this being the 85 degree as my reference angle, I now know the adjacent side A, and I want to solve for the hypotenuse B. So that tells me I want to use cosine. So the cosine of 85 degrees equals B. I'm sorry. The adjacent side, 750, divided by the hypotenuse, which is B. So solving for B, I get B is 750 divided by the cosine of 85 degrees. So I get B is approximately 8,605.285 feet. And last, I want to solve for the height of the mountain. So now 35 degrees is my reference angle, and I know the two sides that I'm using are the opposite side and the hypotenuse, so I am back to sine. So for my third calculation, I'm going to say the sine of 35 degrees is the height divided by 8605.285. So I get my height is approximately 8605.285 times the sine of 35 degrees. So I get H is approximately 4935.785 feet. Okay, and we're done.